Welcome to Accelerated Math 108, Module 11.1, System of Linear Equations, Solutions by Graphing. So in this Module 11.1, we will talk about how to solve what we so-call the linear of, excuse me, we will solve what we so-call the system of linear equation by graphing. So the very first objective is determine whether a given ordered pair is a solution to a specific system of linear equations. So what is a system of linear equation? It's basically a set of two or more linear equations with two or more variables. So for example, normally when you see x plus 3y equal to negative 10, that is referring to as one line. In module, I believe it's in module 10, when we learn how to graph a linear equation, this is only considered as one line. So now if I put two such equations together, they are called a system of linear equation. So we are basically trying to draw two lines. Okay, we're basically trying to draw two lines. So what can happen if I draw two lines? So on the graph, if I draw two lines, the two lines can intersect at one point. That means there is one solution. There's one particular point of intersection, and that's where our solution is going to be. Okay, and that's what we are trying to find through graphing for right now. For in this 11.1, we will find that solution by graphing. If I graph two lines, the two lines could actually not intersect. That means they are parallel. As you can recall, in module 10, parallel lines has equations that have the same slope but different y-intercept. All right. If I draw two lines, they could look exactly the same because the two equation is the same. So basically, these two, if I draw two lines, they are actually if it appear to be one line, that means they are intersecting with each other constantly. So they are on top of one another. That means they have infinite number solution because they're intersecting everywhere. Parallel lines means they have no solutions. All right. So this objective we want to see, determine if this point lies on both of the lines in the system. And the way we're going to do it is by substituting the ordered pair into both equations. So what we're looking for here is, if I substitute negative 4 and negative 2 into x and y, if it's equal to negative 10, that means this point is on that line, or this line carries that point. Same thing for the second line. If I substitute negative 4, negative 2 into the second equation for x and y, if it equal to negative 28, then this line also carries that point. So if both lines carry the same point, then that's where they're going to intersect. And the point of intersection is exactly what I'm looking for. That is where, so that x value and that y value will satisfy the entire system. So let's give it a try. Negative 4, substitute for x. That's just negative 4 plus 3 times y. Now I'm going to substitute negative 2 for y. Does that equal to negative 10? Well, let's see. Negative 4, positive 3 times negative 2 is negative 6. So negative 4 and negative 6 combined is negative 10. So yes, that means this point is on that line, or that line carries that point. Now let's take a look. Let's do the same thing for the second line or second equation. 5 times negative 4 plus 4 times negative 2. Does that equal to negative 28? I don't know. Let's find out. I'm going to use a calculator here. So I'm going to type in exactly like I see. 5 times negative 4 plus 4 times negative 2. Oh yes, it is also equal to negative 28. So that means the second line carries the same point. Therefore, this particular point is going to be the solution, okay, to the entire system. So when you say yes twice, that means negative 4, negative 2 does lie on both lines, or is the solution to the system. It's a solution of the system. How about that? How about I say it like that? Okay. So if you say yes here with negative 4, negative 2, then step number 2 here, determine does 1, negative 3 also lies on both of the lines. All right. So again, take 1 and negative 3, substitute into the x and y for both equations, see if it's true. So let's give it a try, okay? So that's going to be 1 substitute for x, that would be 1 plus 3 times negative 3. Does that equal to negative 10? Well, this is 1 minus 9, right? Positive 3 times negative 3 is negative 9. 1 minus 9 excuse me, is negative 8, not negative 10. So no, this line, this first line, x plus 3y equal negative 10, does not carry 1 comma negative 3. Well, let's see if the second line carry that point. So 5 times 1 plus 4 times negative 3, does that equal to negative 28? Let's see, I don't know. This is 5. Positive 4 times negative 3 is negative 12. 5 minus 12 is definitely not negative 28. It's only negative 7. So that's no again. So that means 1 comma negative 3 is not the solution of the system. Okay, that's what that means. Now, you might ask, well, Mr. Chan, if you already know negative 4, negative 2 is a solution, then why do we even do all this right here? The reason why I still did it is because sometimes two lines can be exactly the same line. So that means they have infinite number of solutions. So I still need to kind of check it to make sure that this second point is not, okay, it's not going to be the solution. If this second point is also a solution, and the first point is also the solution, that means these two lines actually have infinite number of solutions. Okay, so in this lecture video, we talk about what a system of linear equations is, and we showed how to determine whether a point is the solution or not to the system. Thank you for watching.